Hello, hello, testing. Hello, AV Geek IXA, hello, how you doing? Bam. Hello, everyone, thanks for waiting. Today, we're back doing Google interview questions. Let's see. Last time we did lexicographically smallest beautiful string, which was kind of difficult. It is indeed a hard problem. I remember it was like a while loop with 3 different if statements, and it controlled like different phases of the loop. Merge sorted array we did. That was easy. Just go backwards. Keep picking 2 pointers, keep picking the biggest element from each list and moving the pointers. Merge intervals, we just did that. Add 2 numbers. We did that multiple times. The carryover is just really hard. Roman to integer, I think we did. Number of islands we did. But I remember this one was tricky. Excuse me. So I will do this one again. We'll probably do number of islands and this one today. Number of islands. Okay, here we go. Leetcode 200. Leetcode 200. Okay, number of islands. Given an m by n 2D binary matrix grid, which represents a map of 1's land and 0's water, return the number of islands. Right, an island is surrounded by water and is formed by connecting adjacent lands, horizontally or vertically, so not diagonally. You may assume all 4 edges of the grid are surrounded by water. 3, okay, so diagonals don't count for some reason. So it's 1, 2, 3, okay. Hi Gebre, how you doing? Welcome back to the stream. I kind of remember how to do this. You just do depth first search, right? And then, yeah. For every single element, you do DPS, and if it hasn't been visited before, you increase your island count by 1, you visit everything and mark everything connected to it. Yeah, okay. And then you keep searching. Yeah, okay. I mean, just, it sounds easy, just in words, but implementation, it can be kind of icky. Okay, so yeah, for each element, depth first search, you know, if it's not visited before, mark your number of islands ++, visit everything, mark them as visited, and continue. Okay. I think last time we did a separate data structure, another 2D array for storing if they're visited, right? I think this time I want to try in place. I want to try just marking them as 0 if we've already visited them. Yeah. That'll be fun, I guess. Add a twist to it. Okay, let's go. Number of islands. Okay, so once again, we're going to do literally for every single row in the grid, while row is less than grid.length, row++. Again, we want to iterate through everything, so this is necessary. Marissa says, hello, I'm sorry if I need to leave soon. Hand broken and stuff, some weird thing that it hurts when I move my hand up. Oh yeah, you were talking about this last time. That sounds rough. Hope you get better soon, Marissa. That sucks, now you can't draw either. Int column is equal to 0. Column is less than grid dot, well, just the first row's length, column ++. Okay, so now we're iterating through everything. So again, we're doing this in place, right? We're marking it as 0 if we've already visited before. 0 is just don't visit. So if the grid row column is equal to 1, meaning we can visit it. We need to maintain an island count too. Int island count is equal to 0. So if we see a spot that we have not visited before, island count plus plus, and then we need a helper function that's like mark all connected land. Is this a good thing to name a function? It's so long. We'll probably just input the row column here into our helper function. And then we'll define the helper function here, private mark all connected land, int row, int column. Let's do void for now, and then just do nothing here. Okay. And then we'll, just for a sanity check so far, we will do return island count. Okay, very nice. Give me a moment while I sign in so I can run my code. I always forget to log in. Okay, let's run this thing. How many compilation errors do we have? Oh, we have no compilation errors. Nice. Okay, our output is all 0 though. Is that right? Oh wait, these are all characters. We should be doing a character of 1. Okay, so what to expect here? We should just be taking the count of all the ones, right? So 1, 2, 3, 4, 5, 6, 7. This should output 7 for case 2. For case 1, it should be 1, 2, 3, 4, 5, 6, 7, 8. So 8, 7, 8, 7. That's our expected output for now, because we don't mark anything as visited. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I miscounted. Check cannot count. 1, 2, 3, 4. Yeah, 7. Very nice. Sanity check is successful. Okay. Oh, Gabriel says you are not sharing screen. Oops, sorry about that. But yeah, so far all it does is count the number of ones in the grid. So we counted 7 ones here, 9 ones here. Yeah, sorry about that. Okay, now is the tricky part. Now we need to do the depth first search to mark all the visited land as visited. And we're going to do this in place too. So we should probably pass this grid into... Oh man. Okay, how in the world do we do how do we do this? Okay, so some really simple cases are, if it's already 0, right, then we just don't do anything. And if it's 1, we need to look at, oh, the top, bottom, left, right? Okay. So I guess some common base cases are if the row is less than 0, you know, if stuff are out of bounds. So if row is greater than or equal to grid.length, or column is less than 0, or the column I cannot type today, or the column is greater than or equal to grid 0.length, you know, the length of the first row, the number of columns in the first row. Then you just do nothing, right? Right. Return? Sure. What happens if you're 0, 2? If grid row column is equals to 0, then you also return. I could probably combine these two statements, but I think it might be more readable like this. This is just out of bounds. This is, you literally cannot step on land. It is claimed by another territory. Or you already claimed it, I guess. Okay, now the really difficult part. Recursion. How do we visit the top, bottom, right, and left? Wait, this isn't that bad, right? All connected. Because I've already handled it out of bounds, I can just do grid. Okay. Top is row -1 column. That's the top. Wait, this isn't that bad, is it? Was I just overthinking this? We don't have to handle diagonals too, so it makes our life way easier too. So top, bottom is +1. What is column? Column +1. So this is right. Right. Column -1 is left. I feel like that's it. Sai says hi. Hello Sai, how you doing? I feel like this is it. Am I tripping? Am I underthinking this? Oh. Yeah, I'm underthinking this. I never marked any of the land as visited. Okay. So grid, row, column is equal to 0, or set it to 0. This should be a character too. Right, okay, so if it's out of bounds, return. If I can't step on the land because I either visited or it's water, return. Else you visit it by marking it as 0, I guess. That hehe kind of sounded like a child. He just said something like, yeah, I took all the candy. Is this how you do it? Sure, let's run this. I have no idea what else to add. Compilation error. Oh, I'm dumb. This is a comma, not a semicolon. Dang, bro. Dang, it worked. Dang, it worked. I'm at the top of the world. In terms of height, not in terms of speed. Alright. Cool. That was pretty smooth. I guess we definitely don't need to mark this question for review. That was pretty fast. Okay. Whew. What else do we do now? We just did number of islands. Gabber says nice. Thank you. Recyclable and low-fat products. Is this a premium question? 1757. I think I wanted to do this problem in one battle before. but I couldn't, maybe because it was premium. 1757. Leetcode 1757. Please don't be premium. Oh, yes. Oh, I see why we didn't do this. This is a SQL problem, which is completely useless to me in coding interviews, because I'm not applying for data analyst roles. In case you don't know, SQL is a coding language for asking questions to databases. That's not my profession, so. Varnit says, what job you are applying for? I'm applying for back-end engineering jobs. Yeah. The name of the question sounds so wrong when taken out of context. Really? Recyclable and low-fat products. Really? Why? Recyclable and low-fat products. What can you possibly interpret this? SDE1 at Google? I don't know what the ranking systems of the SDEs are at Google. Probably as like one level above the most bottom tier junior level, because I have some experience already. Okay, so we don't do this one. No SQL. Trapping rainwater starts at 1. Okay, then probably 2. Yeah. No, do we want to do another hard problem? I don't want to do another hard problem already. We've done hard problems the past 2 days. Varnit says, yeah, I was not able to find a job opening for SDE1 at Google website. Yeah. I feel like openings at Google are pretty much drying up. I actually applied like, I forgot, 2 months ago, 3 months ago. Yeah, I didn't get any callbacks. So once the, what's it called? The buffer time or expiration time goes away, I'm gonna apply soon. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. How? Sure, you know what? Let's attempt this one. Leetcode 42. My brain is probably going to die after this one, but it's okay. This is Leetcode 42, okay. Leetcode 42. Varnit says, I know this is a 2-pointer problem. Ooh. That's useful to know. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water you can trap after raining. Okay. Okay, so here, how do we know how much water can be trapped here? I guess we're assuming that this is like just negative infinity here, like this is a cliff here. So at 0, all the water is going to flow off the cliff. What about here? What about here? Okay, so what I observe is the maximum if I go this way to the left is 1. The maximum if I go right over here is 3, I guess. This is kind of like that other problem we did, right? Martin says, have you solved container with most water? Yeah, I have. Yeah, that's the problem I was referring to, the 2-pointer one. Oh wait, the 2-pointer one. Wait. Do we do the same 2-pointer method here? Is that gonna help us in any way? So I have 1-pointer here, 1-pointer here. It's like, okay, the maximum is... Wait, is that gonna help us? I don't know if that's gonna help us. Do we do it for every single? Martin says, I subscribed. Gonna practice some sliding with and probably catch you later. Oh, thank you. 2-pointers. Okay, so, but what I observe right now is that the amount of water we can trap at any given point is the... I guess you take the maximum, the local maximum on both sides. In this case, this is 1, this is 3, and you take the minimum of those. So this is 1. Like over here, you take the maximum on the left is 2, and the maximum on the right is 3, so you take 2. Huh. Alright, I'm gonna set a timer here. If in like say 15 minutes I don't get this, I'll just probably take a peek at the solutions. How does 2-pointer help us here? Let's say we set 2-pointers here, right? So pointer 1 is here, pointer 2 is here. What does that even tell us? Beats me. Well, do we slide this pointer in because it's like killing us? Huh. You know what? Let's take a look at the hints if there's any. There is no hints for this. No. Okay, well, the complete brute force method would be for every single spot, calculate the local maximum on both sides. And then take the max, that's your max. Take the min, that will be your water height times 1. Wait, hold on. Okay, this is definitely not a 2-pointer thing, but what I'm thinking is 2 reverse priority queues. Priority queues. So if we're like here, so 1 representing the left and 1 containing the right stuff. Oh, take care, Marissa. Get well soon. What if I input everything on the left into the left reverse priority queue? So, you know, the maximum is going to pop off of it. That's the thing we're going to pull. And then everything on the right. Wait, that's not going to work. I was thinking we could, like, every time we shift one element down, we can, you know, I don't know, exchange, move whatever is immediately on the right to the left priority queue, but that's not how priority queues work. We only get the maximum. Is this actually 2 pointers? I cannot tell. Xavier says it is, but it's tough. You know what? I am stumped. Time to take a peek at the solutions, which I need Leetcode Premium to have. Okay, here is brute force. Yeah, you find the left max, right max, left max, right max, minus height to answer. Okay. Left, right, and then keep the max. Dynamic programming, what? This is dynamic programming using stacks. Using 2 pointers. Wow, complexity just O of n, O of 1 extra space. How much is dynamic programming? Is it much more expensive? Time complexity O of n, space is O of n. Okay, 2 pointers. Oh, hi Reified, how you doing? Welcome back to the stream. Instead of computing the left and right parts separately, we may think of some way to do it in one iteration. Okay, algorithm. Initialize left pointer to 0 and right pointer to size -1. Make okay. While left is less than the right, do if height left is smaller than height right, okay. If height left is greater than or equal to left max, update left max, okay. So you're tracking your left max as you move your pointer in. Else add left max minus height left to answer. Left max minus height left to answer. Why? Why do we do that though? Left max minus height left. Oh, I see. So like here, my max height is 2, but my current height is 1, so I can only fill 1. Got you, okay. Add 1 to the left. Okay, and then else, height right. If right is bigger than, sure, here it's if right is bigger than the left, update right max. Else add right max minus height right. Right max minus height right to answer. Okay. Okay, I understand what they're doing, but I don't know why it works. Okay, left is here, left max is 0, right is here. Let me zoom in so y'all can see. Okay, 2 pointers start here, left, right. So we update the left max, okay. We update the right max to here, so now it's 1. All right. Sure, okay. Left height is greater than or equal to height to right. Okay. Left goes to here. We update the max, I suppose. Okay, left. So we get to here. Answer is equal to 1 minus 0, which is the max minus the current height. Okay, so yes, I understand that we have a max left somewhere to our left, and we can definitely fill out space here. But how do we guarantee that the right has, you know... Oh, wait. I think I see it. We don't care what the maximum to our right is, do we? We really don't care. We don't care that this is 3 over here, because it doesn't matter, because we'll always take the minimum height. Okay. And worst case, the best height we found on the right is 2, right? Which is already guaranteed to be bigger than us. So 1 is guaranteed to fill no matter what here. Yeah, it really doesn't matter what the maximum on the right is. Even the second best we found so far, 2, doesn't matter, because as long as we know there's something bigger than it on the left, then we can fill it up. Yeah, okay. Got you. Okay. So all we need to do is 2 pointers. Keep moving them in depending on which one is smaller, and then keep tracking the local max at each. Yeah, okay. And then if the current ground level is lower than my max at either side, yeah, okay. Then you calculate the water level, and then you're good to go. Yeah, okay. Yeah, finding the maximum, the clear maximum at either side at any given time isn't needed, because we don't care what the maximum is. We just care what the local sort of max minimum is, I guess. All right. This is okay. Implementing this will be a whole nother monster though. Okay, back to my own account here. So 2 pointers, int left is equal to 0, int right is equal to height dot length minus 1, left max so far, this is just so far, is equal to 0. All the heights, yeah, all the heights are 0 or above, so this is reasonable. Easier for me is to compute left max array and right max array for each index. Oh, I see. Yeah, I guess that works too. Yeah, you're computing the local max at each position, right? I think that makes sense too. That's basically what we're doing. But we're doing it with less storage, I suppose. Int right max is equal to 0. Sure. So while the left is less than the right, GetReady says, but that's extra space. Yeah, true. Okay. Now to implement the algorithm that I have barely wrapped my brain around. Okay, how do we do this? Do we keep track of Okay, so what do we do? Everyone is at 0 right now, right? So we can't possibly support any water. Or can we? If the left value, wait, if the height at left is smaller than the height at the right, then that means we can possibly calculate the thing at left, right? So also we need int water is equal to 0. So we'll only calculate this if the current height is greater than our left boundary level. And if our current wait wait, I'm kind of blanking out. What do we do here? Should we do this based on the max heights? Wait, let me take one more peek. I'm confused. Okay. If the height on the left is less than the height on the right, like what if we're here? I'm trying to think about how the algorithm will work in this spot. Or is that not a good place to think about? What about if we're here? Should we update our max height over here? Sure, let's see what happens. Left max is equal to math.max, the current left max, and the height, the current left. Sure. So if we move away from here, our left max is currently 0, left plus plus. Is that the right decision? What if we're over here now? Or what if we're over here? The water level is 0. I mean, the ground level is 0. Left max should be 1 now. Should we calculate the water level first? Water plus equals left max minus the current height okay. Okay, I feel like that's okay. Because I'm thinking, what if we're here, right? Is the height... height left is less than the height right. Water plus equals to left max minus height left and then you update the max, and then update the left, okay? Sure, and then else here, the right is greater than the left. What do we do here? Water plus equals, well, water plus equals the right max minus height right, and then you update the right max. Right max is equal to math dot max the current right max and the current height right. And then right minus minus. Right minus minus. Okay. I feel like we should only do this if the current height is less than the max. Okay. If the current height on the left is actually less than left max, then you do the calculation. Otherwise, you'll get a 0 probably. Same for here. If height right is less than right max, so much typing. Okay. I'm still kind of iffy on the if conditions here. Should we do this based on the left max or the right max? Why does my gut feeling tell me this should be based on? Because what does the current height have to do with anything, right? Left max less than right max? Is that how it works? Okay. Sure. Let's try running through this by... oh. Return water. Okay. Let's try running through this in an example over here. I guess currently we both start off at left is here, right is here. If left max is less than the right max, they're both 0, so height is equal to so this doesn't matter. Left max is equal to 0 still. Okay, and we get to here. Everything is still 0, so it doesn't matter. Left is now equal to 1. You know what? I'm so confused. Let's just try running this once. Wrong answer. No. Okay, maybe I didn't understand this. Okay, so their solution, they did left is equal to 0, right is equal to the right. Yes, answer is 0. Left max is equal to 0, right max is 0. While the left is less than the right, if the height left is less than the height right, okay, left max is equal to this answer plus equal to left max minus height left. Gabriel says, so at each index you are asking, is there a longer wall to my left? So at each index you are asking, is there a longer wall to my left, the biggest one? If there is, at the current height, I can have a possible buggy with left max and my current height as walls. Oh shoot. Wait, hold on. If left is less than the height right, Brutic +2 says, hi bro, remember me? Sorry, I genuinely don't. Welcome back though. I appreciate your return. Wait, hold on. I still don't get this. You're saying we use this as a boundary? If the current height left is less than the current height right, notice that as long as right max is greater than left max from 0 to 6, the water trap depends on the left max. Okay, and similar in the case when left max is greater than right max. Yeah, okay. So we can say that if there's a larger bar at one end, say right, we are sure that the water trapped would be dependent on the height of the bar in the current direction from left to right. As soon as we find the bar at the other end right is smaller, we start iterating in opposite direction from right to left. As soon as we find the bar at the other end right is smaller, we start iterating in opposite direction from right to left. Okay, I think this is the key here. As soon as we find the bar at the other end right is smaller, Predict says, bro, in this trapping way model you have to make 2D array. Should I read about dynamic programming? We iterate over the left and right parts again and again just to find the highest bar size up to that index, but this could be stored. Dynamic programming. First max height up onto the given point on left hand, first right height up to the given point to the right. Okay. Find the maximum height of bar from left and up to the index. Okay, so the current maximum basically. Ooh. You know what? I think I'm having a hard time understanding fully the intuition behind the greedy algorithm. I think I'll definitely try the dynamic programming way then. No, we have to start over. I'm looking at approach 2, by the way. Okay. Screw the greedy algorithm. Let's try dynamic programming. Okay, so int local left max is equal to new int height dot length You know, maybe if I solve this, the greedy one will become a bit more understandable for me. Excuse me. Like while making first array, you should fill the element in the way that if suppose you are filling array 1, then look, you have to look bigger elements in the right side that fill that element at that position. Remember you already checked the current. While making the first array, you should fill the element in the way that if suppose you are filling array 1, then you have to look bigger elements in the right side that fill that element at that position. Wait, are you saying that I have to make... Are you saying that... Wait, I don't understand what you're saying. Am I supposed to do like 1 off? Or something? Okay, let's fill... So this part here, fill local left max. Prefix max, suffix max. Oh, okay. Okay, I know what you're saying then. 0, I is less than height, length, I plus plus. Okay. And sum is equal to 0. And in second array, you have to find the max for a greater element in the left side. Second array in the left side. Well, in my case, second array is right max, so I start from the right to the left. Okay, I think I understand what you're saying though. So local left max from the left is... Wait. Let's name this current sum, and then current max sum is equal to 0. Okay, so I index 0. Then compare both array of which element y is minus them. Okay, I see what you're saying then. Thank you. According to the answer, increase count value. Got you, okay. So here, current sum plus equals height I. That's my current sum. Local left max I is equal to to what? Current sum oh, I have to calculate the current max sum too. Current max sum is equal to math.max current max sum. Oh, okay, so it doesn't matter if I'm bigger than my left too, because if I'm bigger, then there's no water here anyways. Okay, I think that makes sense. For a current location, assuming you know the prefix max and suffix max to that position, then water you can have is a difference between the current height and smaller wall from the prefix / suffix. Wait, hold on. I gotta read that more carefully. For a current location, assuming you know the prefix max and the suffix max to that position, then the water you can have is the difference between the current height and the smaller wall. Oh. I think I understand what you're saying. Okay. Yeah, the minimum of my left and right minus my current ground level. That's the water level. Okay. People are helping in the chat. Thank you. I see. Okay. I think I see what you guys are saying though. I think I see it. Current max sum, local left max I is equal to current max sum. Okay, and then we do this for the right. So local right max. Current sum we reset to 0. I is equal to height dot length minus 1, while I is greater than or equal to 0, 9 minus minus. Current sum plus equals height I. Current max sum is equal to math.max, current sum max. Local right max I is equal to current max sum. Okay. Those should be the prefix sums. Okay. Should we do a sanity check? Print these out. System.out.println. Let's print the left one first. Arrays.toString local left max. And local right max. Let's see if our prefix and suffix sums are correct. Where is this? Line 11. Oh. I'm missing a semicolon. Math.max. Oh. Current max sum as well as the current sum. Okay, run. And let's return -1 for now, just as a bogus value. Okay. Oh wait. I don't need the Kim sum, do I? I just need the biggest value. Okay, I'm doing this wrong. Yeah, I see again, right? No, I don't need the current Kim sum. That's like useless to me. Yeah, I just need to keep track of the current biggest one. No. Yeah, I was going about this wrong. I should be doing current max. Yeah, just current max. So current max is equal to math.max, the current max, and height I. Oh, that's why you guys are messaging me earlier. I was doing the sum. Oops, my bad. Yeah, okay. Oh wait, I have to do this all again. Height dot. This one greater than or equal to 0 minus minus. One 6 6. Wait, you're saying the first array in that example should be 6 6 5 5 5. Second array should be 1 6 6 6 6. Okay, that's the from the left. Wait, I don't get it. Why is the first array 6 6 5 5 5 4 4? That doesn't make sense to me. It's the maximum from the right, is it not? The maximum from the right. Oh, wait. Okay, thank you. Gabriel says I'm correct, apparently. Local right max is equal to this. Okay. Current max is equal to math.max, the current max. Okay, let's try running this. Okay, so this is our prefix. 0, 1, 1, 2, 2, 2, 3, 3, 3. Okay, that looks right. All the way here is from the right. 1, 2, 2, 2, 2, 3. That looks right to me. Yeah, okay. And then one more iteration to count what the local, the water level at each. Okay. So now it's time to compute all the water levels. Int water is equal to 0. Copy this for loop again. Okay, calculate water levels. Okay, so for each position, we do water. Let's store this in a separate variable. Int current water is equal to, so local map.min, the local left max, comma, local right max, I, basically the lowest boundary on either side, right? Because that's what governs how high my water can go. The min of the max of my right and left. Okay. Minus my current height, my ground level. Okay. So for example, here or here, my max to the left is 2, 3. I would take 2 over here. 2 minus 1 is 1. Okay, that works. What about here though? 3. Wait, does this not work for 3 here? My left will be 2. Right would be 2 as well. Or 3. Wait, 3. It would be 3. Left and right will be 3. Min local, so it'll be 3 minus my height 3, which is 0. Okay, you know what? This makes sense to me. Return water. Run. Uh-oh. Output is 0. Oh, I never added the water. Water plus current water. Let's go. Let's comment out these print statements. Yep, we got it. Yay, let's go. Brutic sent me another thing. Look now, give array 0, 1, 0, 2, 1, 0, 1, 3, 2, 1. Now first in first array, you should start filling element by looking at the rightmost side max element. Let's suppose for array 5 element for you. Oh yeah, you're still telling me about filling up the suffix array, huh? Should look the element 6, 7, 8, 9. Then, which is max element, you should fill that on that indices. Yeah. I think you're talking about this thing, right? The suffix thing. Bro, tell me, what are you preparing for? Oh. That's a good question. What am I preparing for? I have a friend who works at, well, I have a connection who works at Google. They might be able to connect me with a recruiter. It's not 100%, it's a small chance. So yeah, I'm preparing for the the miracle that they can somehow connect me to a recruiter. And then I get an interview opportunity. Yeah, that's what I'm preparing for. But otherwise, I was interviewing for a bunch of smaller companies. So yeah. Bro, are you in CLG? What is CLG? Oh, am I esports? Certified local government program? Where are you from, bro? College. Well, I don't think I want to tell you what college I'm from. I'm from California, though. Yeah, California. I'm not in college, by the way. I'm not going to tell you which college I went to. Too much information. Okay, so this problem, I'm definitely going to mark it down for review. This took way too long, man. So this is Leetcode 42. Whoop. 42. I have starred that problem on my notebook. Oh, CLG means college, and where are you from? 2 different questions. Oh, hey Velveteen, hello. Also, what am I gonna do with your CLG name? You could potentially find out like who I am. But yeah, nothing against you. It's just a personal thing. I don't really give out too much personal information online. Though I realize I just said I'm interviewing for stuff. Oh well. Alright, it's time for the part of the stream where we study some system design. Hi Velveteen. Gonna get out the board and red yarn. Bro, have you done any internship or job before? Ooh, interesting question. I have. How much should I say about that? I have done an internship before. Do you guys want to hear some internship stories? I had an internship during the pandemic, so it was all remote. It was for a travel company. They have a travel website. They help people book travel packages, basically. On the front of their website, they have a chatbot. On the, lower right-hand corner of the website. I forgot if it's still the same format. But that's how it was back then. Tuka says, hello. Yo, hello, how you doing? But yeah, I had an internship for, a travel company. I helped them work on their reinforcement learning chatbots. They trained their own chatbots with TensorFlow and reinforcement learning. This was before ChatGPT became super popular, by the way. I think I checked on their LinkedIn status and their chatbot team got fired. A lot of people got laid off because they started using ChatGPT, so I'm glad I did not take their return offer. But anyways, I helped them work on their reinforcement learning chatbots. I basically helped make it easier to train the chatbots. I remember they also told me to help them look into Microsoft Azure. I think Microsoft Azure had a product called Lewis. Azure Lewis. Yeah, language understanding. Right now, I'm pretty sure this is pretty obsolete because ChatGPT is all the rage now. But they asked me to play around with Lewis and try to help them figure out if it's a, useful thing. So you know what I did? I made a chatbot for them that recognizes JoJo references. So for example, a user could potentially type like, how do I describe this? A user could type like muda 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 into the chatbot, right? And then it would be like, oh, you're making a JoJo reference to, was it Dio? You just made a reference to Dio from JoJo. Dio appears in whatever arc. Whatever arc takes place in Egypt. Would you like to book a trip to Egypt? Yeah, that's how it ties it together. It not only recognizes the JoJo references, but it also makes trip recommendations based on the JoJo references. So then that way, it provides value to the company because it's a travel company, right? That sells travel packages. Yeah, so how I built it was they actually gave me some machine learning courses. One of the subunits was how to build a web scraper. So I used my newfound web scraper knowledge and I made a web scraper bot. I made a web scraper bot that parses the JoJo fandom wiki. It extracts all the information, from the 10 most important characters. And then it puts it into Azure Lewis. What Azure Lewis does is, well, one of its, is it going to say it over here? It recognizes intents. Yeah, it recognizes intents. Basically, an intent is like supposed to be like an emotion, right? Like happy, sad, whatever, or perhaps what your customer wants to do. For example, if your customer would like to cancel a trip, you can name it an intent like cancel trip, and then you can feed it a bunch of sentences that imply the customer wants to cancel their trip. And then it would learn how to detect sentences that are for canceling trips. That are what? Basically intent recognition. So what I did was I made 10 intents, one for each JoJo character, top 10 JoJo character, and then I scraped the JoJo wiki fandom of sentences that have to do with the character. I input it into the intents for each character, and now the chatbot can recognize JoJo characters based on intents. And then I had a map data structure that maps each JoJo character to a trip recommendation. And that's how the chatbot works. So user enters, I don't know, I don't remember any JoJo references now. Purple Hermit or something. And it's like, oh, you're making a reference to Joseph Joestar. Joseph Joestar appears in whatever arc, which appears in whatever location. You want to book a trip to whatever location? Yeah, it's pretty awesome. I got to demo this slide, by the way. I even had one audience member make a JoJo reference for me to plug into the machine. I was so nervous, by the way, because this thing did not work 100%. It probably worked like 55% of the time. So I was taking a huge risk just by asking that person to make a JoJo reference. But anyways, the reference the person made was Hermit Purple or Purple Hermit, something like that. And I remember when I heard that, I absolutely panicked. I panicked so hard because I had not watched Arc 3 yet. I did not know what Purple Hermit was. So I had not tested this input before into the chatbot. So I was like, oh no. As I typed Purple Hermit into it, I was like, please work, please work. I have no idea if this is gonna work. I have no idea verifying if it works either. So I typed Purple Hermit in, and then I made a recommendation, and then I looked back at the person, I was like, is that right? And he was like, that's right, that's so cool. And then I looked so good. I looked so good. And I got the return offer. They were impressed. Yeah, I got the return offer. It was awesome. I did not join them though. I did not join the company because at that time COVID was hitting its peak and the travel industry was tanking. So it looked like a really risky option. I went with some other company. Yeah, and I remember later in my career, I looked at their LinkedIn profile again, at my old manager, and it looks like they were having layoffs because ChatGPT was taking over their jobs. So it was kind of sad. So I guess it wasn't a bad decision to not go with them. Yeah. So yeah, everything I learned there was probably kind of obsolete now because ChatGPT. Yeah, paying for all those engineers. I remember there was a time where I looked on LinkedIn and they were all open to work because, yeah, they got automated by ChatGPT. It's kind of sad. Good luck to them though. Wish them all the best. Oh, see, look. Lewis will be retired on October 1st, 2025. Yeah, it's kind of obsolete now. This is like super basic compared to what ChatGPT can do now. We recommend migrating your Lewis application to conversational language understanding. What is this? I guess their new thing. Okay. I'm guessing it's their LLM. Okay. Yeah, rip Lewis. Lewis really carried me on my internship. This dude. This dude helped me get a return offer. Thank you, Lewis. You will be missed. Rest in peace. Oh wait, it was already obsolete starting April 1st, 2023, because you can't create any new Lewis resources. Yeah. No. That means my chatbot feature doesn't work anymore to this day. No. Velveteen says, hopefully companies eventually realize that not everything needs something as advanced as ChatGPT. Yeah. Man, I was rambling a lot. Yeah, that was story time of my internship experience. It was fun. Okay, what were we doing? Oh, I know. We were studying system design. Velveteen says, I liked it. Oh, thank you. I appreciate. Man, we've been stuck on this for like 2 days now, huh? Cursed Twitch and ruining my emote icons. Okay, we were learning how to make Google Drive, right? You know what? Since my story was a little bit too long, I might just review what I learned last time and then save the deep dive for next time too. I'm not in any rush to learn Google Drive either, so it's fine. Okay, what did we learn last time? This is for uploading. Okay, this is for uploading a file, right? And also retrieving a file. Okay, so most APIs go through the load balancer to the API servers. But when you're uploading a file, you go through the block servers, which cuts up your Google Drive file into smaller blocks so it can work in parallel on them. And then it uploads all those blocks of your file into cloud storage, possibly Amazon S3, since it supports replication of your files, so it makes it more available. And if one server dies, your file will still be preserved. Yeah, possibly one bucket or folder per user. So anyways, you upload your file through the block servers to the cloud storage. And then once it's done, the cloud storage goes through the load balancer and tells the servers possibly that, it's done, and it can update your metadata saying that your file has complete uploading, yay. Yeah, and then when you're done uploading, it'll probably go to a notification service, so it can notify your collaborators that the file has been updated, and then it notifies the users, or if the users are offline, it puts it into a backup queue for whatever else it needs to do. Then when you try to retrieve the file, you go through the load balancer, your API servers, it retrieves from the cloud storage what the file is, and then it returns it back to you. Then there's the cold storage thing. This is for files that have are like not commonly retrieved, I guess. Cold storage services are apparently like really cheap in terms of storage, like cheaper than S3 apparently. But retrieval takes a long time, and retrieval is expensive apparently. Yeah, its advantage is for cost-effective storage for underused files, basically. Yeah, that's basically what we learned last time, right? What else did we learn? Oh yeah, for conflicts. So in this design, if there's a conflict, it's first come, first win, right? First come, first win. One user, yeah, whoever modifies it first, if there's a conflict, wins. And if there's a conflict, we keep 2 of them. Yeah, the first change gets baked into the first original version, and then we acknowledge to the user that there's a conflict with a separate version, and they can handle it themselves. Yeah. Alright, yeah, and S3 probably handles sharding itself through multiple servers, so. Okay, design deep dive, the block servers. Yeah, we'll probably look at this next time then. My throat is already kind of giving out, and my phone is out of battery. Yay. Okay, that's it for this stream then. Yeah, we'll do design deep dive next time. We did a hard problem today and a medium problem today. Today was pretty okay in productivity. Alright, bye guys. Enjoy the rest of your day. I'll see you guys tomorrow, maybe. Well, tomorrow might be the release of Yohua versus Chet, my battle with Yohua on YouTube, so maybe I won't stream. I typically don't stream when I release long-form videos on YouTube. So, yeah, we'll see. Maybe I'll stream, maybe I won't stream. Maybe a long-form video will be out, or maybe it'll be out on Saturday. Who knows? Bye guys. See you next time. Bye. Bye Reified. Bye Gabre. Bye Velveteen.